The mortar round hit 200 meters outside the wire, close enough that Staff Sergeant Maya Torres felt the pressure wave through her chest. Firebase Cost shuddered under the impact as she sprinted toward the artillery pit where her M777 howitzer crew was already scrambling into action. The counter-battery radar had pinpointed the enemy position. They had maybe 90 seconds before the next incoming round. Sergeant First Class Dalton was shouting coordinates to the crew. Get that gun up. Fire mission. Enemy mortars, 8,000 meters. Torres reached the gun pit as Private Jenkins slammed a round into the breech. The howitzer roared, the barrel recoiling backward in its hydraulic buffer system. Except it did not stop recoiling. The entire gun assembly lurched violently, the barrel dropping at a sickening angle as metal shrieked against metal. Torres saw it immediately. The hydraulic buffer housing had cracked, spilling fluid across the gun carriage. Dalton stepped back from the sight. That is done. We need to call this gun deadlined. Torres moved closer, examining the recoil spring through the damaged housing. The spring itself was intact. The hydraulic system had failed, but the mechanical components were salvageable. I can fix this, she said. Dalton turned to face her, his expression flat. We need an armorer, not theories, Torres. This is not a timing belt on your Honda. Torres ignored the dismissal and knelt beside the buffer assembly. The recoil spring housing is cracked, but the spring is good. If we can control the recoil externally, we can bypass the hydraulics entirely. Jenkins exchanged a glance with Corporal Martinez at the ammunition station. Martinez shook his head slightly. Another mortar round impacted closer, maybe 150 meters out. The Firebase command post was already calling for counter-battery fire. Every second the gun stayed offline put more Marines at risk. Before we're all from different corners of the country, I am curious, where are you watching this from? What state calls you home? Does your area have a strong military presence or bases nearby? Drop a comment and let me know, because that sense of home, that is exactly what these soldiers were fighting to protect in that moment. Dalton crossed his arms. Captain is not going to authorize field modifications on a primary weapon system, especially not, he paused, experimental ones. Torres could hear what he did not say. Especially not from you. She had dealt with it for 8 months since arriving at the firebase. The doubt, the hesitation, the automatic assumption that someone else should handle the technical problems. Torres stood up, keeping her voice level. Then we have a deadline gun and no fire support for the northern sector. Your call, Sergeant. She walked toward the maintenance shed, not waiting for permission. Behind her, she heard Jenkins mutter to Martinez. $20, says the captain does not let her touch it. Martinez replied quietly. I am not taking that bet. The next mortar round landed inside the wire. Torres returned from the maintenance shed carrying a tactical cargo strap rated for 10,000 pounds and a coil of steel cable. The crew had pulled the protective cover over the damaged howitzer like they were preparing it for transport to the boneyard. Dalton stood 20 feet away, speaking into a radio handset. She caught fragments of his transmission. Request immediate armor support. Primary fire system compromised. Hydraulic failure. She set the equipment down beside the gun carriage and pulled back the cover. The recoil spring gleamed in the afternoon sun, still perfectly coiled despite the shattered housing around it. Jenkins approached cautiously. Sergeant Torres, the captain is probably going to want to wait for proper repair parts. We have got the other guns covering our sector for now. For now, Torres repeated. She ran her hand along the barrel assembly, checking the mounting points, until the enemy adjusts their position and finds the gap in our coverage. Then what? Jenkins did not answer. He glanced back toward Dalton, who had finished his radio call and was walking toward them. Torres, step away from that weapon, Dalton said. His voice carried the weight of rank and finality. Captain Rodriguez is inbound. He will make the call on repair procedures. Torres straightened but did not move away from the gun. With respect, Sergeant, the captain is going to ask what options we have. I would like to have an answer ready. Dalton stopped a few feet from her. The answer is we deadline this gun and wait for parts. That is the answer. That is the only answer that does not risk catastrophic failure and dead Marines. Torres met his eyes. The catastrophic failure already happened. The hydraulic buffer is destroyed. But the recoil spring, the carriage, the barrel, the breech mechanism, all functional. We're not talking about making this gun pretty. We're talking about making it shoot. Martinez had moved closer, listening. His arms were folded across his chest. You want to fire this thing without a hydraulic buffer? That is what absorbs the recoil energy. Without it, the whole assembly could tear itself apart. Torres nodded. Correct. Without the hydraulics, we need another way to absorb and distribute the recoil force. She pointed to the steel cable and cargo straps. We create an external dampening system. Use the principles of tension distribution, same way a suspension bridge handles dynamic loads. Jenkins frowned. A suspension bridge does not have explosions going off inside it. Torres allowed a slight smile. True, but the math is the same. Force, tension, distribution points. If we anchor the barrel assembly to the carriage with heightened style cables at calculated positions, we can control the recoil mechanically instead of hydraulically. It will not be smooth. It will not be pretty, but it will work. Dalton shook his head slowly. You are talking about turning a precision artillery piece into a field-rigged contraption. Even if the math works on paper, you're assuming those cables hold under combat conditions. You're assuming the anchor points do not shear. You are assuming a lot. Another mortar round impacted somewhere beyond the perimeter. The distant crump of the explosion reminded them all why they were having this conversation. I am not assuming anything, Torres said. I am calculating. She pulled a small notebook from her pocket, the pages filled with diagrams and equations she had been working through since seeing the damage. Load-bearing capacity of the cables, recoil force of a standard high-explosive round, stress points on the carriage. The numbers work. Dalton took the notebook, scanned the pages without comment, then handed it back. The numbers might work, he said, but Captain Rodriguez has to sign off on this. And I'm telling you right now, he is not going to authorize an untested field modification on a weapon system that costs $2 million. Torres slid the notebook back into her pocket. Then we ask him. That is all I want. A chance to present the option. Captain Rodriguez arrived 10 minutes later, his uniform still dusty from diving into a bunker during the last mortar impact. He listened to Dalton's summary of the damage, then turned to Torres. Sergeant Torres, I understand you have a proposed solution. She laid it out in 2 minutes. The physics, the materials, the risk assessment. Rodriguez listened without interrupting, his face unreadable. When she finished, he was quiet for a long moment. How long to implement? 2 hours, maybe 3, Torres said. And you're confident this will not result in a barrel separation or carriage failure. I am confident the math is sound, sir. Rodriguez looked at the damaged howitzer, then at the other guns in the firebase, already firing at maximum sustainable rate. He turned back to Torres. You have 2 hours. If this works, we keep fire support on the northern sector. If it fails, we have lost nothing we have not already lost. But Torres, if anyone gets hurt because of a structural failure, that is on both of us. Understood? Understood, sir. Rodriguez walked away. Dalton stood motionless for a moment, then gestured to Jenkins and Martinez. You two heard the captain. Sergeant Torres needs materials and support. Get done. His tone suggested he expected this to be a wasted effort, but he would follow orders. Torres was already measuring cable lengths. She had 2 hours to prove that theory and practice could align under pressure. 2 hours to show them she knew exactly what she was doing. Torres began by removing the shattered hydraulic buffer housing. The damaged metal came away in pieces, revealing the recoil spring beneath. Jenkins and Martinez worked beside her in tense silence, following her instructions to clear the hydraulic fluid and disconnect the failed system. Dalton observed from a distance, arms crossed, occasionally checking his watch. 40 minutes gone, 1 hour 20 remaining. She laid out the steel cables in parallel lines on the ground, measuring each one precisely. The primary load-bearing cables needed to be identical in length to distribute force evenly. Martinez handed her the bolt cutters. You really think cable is going to hold back the recoil force? His tone was not quite skeptical, more curious than dismissive. Torres cut the first cable to length. These cables are rated for 10,000 pounds each. The recoil force peaks at around 8,000 pounds. With 4 primary cables plus the secondary stabilizers, we have redundancy built in. Jenkins positioned the first anchor point on the gun carriage where Torres indicated. This is not in any manual I have ever seen. Torres secured the cable end through the anchor bolt. That is because nobody has needed to do this before. Does not mean it will not work. She pulled the cable taut, testing the tension. The steel hummed slightly under pressure. Good. That is what we want. Controlled flex, not rigid lock. The work progressed methodically. Each cable had to be positioned at a precise angle to the barrel assembly, creating a web of tension that would absorb and redistribute the recoil energy. Torres explained as she worked. Think of it like a spider web. The spider does not make every strand the same thickness. The radial threads are strong. The spiral threads are flexible. Together they catch insects 10 times the spider's weight. Same principle here. Strong primary cables, flexible secondary stabilizers. Martinez tightened a ratchet tensioner on the second cable. How do you know this stuff? Torres glanced at him while threading the third cable through its anchor point. Mechanical engineering degree before I enlisted. Spent 2 years designing industrial equipment. Most people do not know that. They see the uniform and make assumptions. Martinez nodded slowly, but said nothing. Dalton, check his watch again. 1 hour 15 gone. Torres, you're cutting this close. She did not look up from the cable she was securing. I am aware of the time, Sergeant. The 4th primary cable was the most critical. It had to anchor to a reinforced point on the carriage that was designed for towing stresses, not recoil absorption. She positioned the cable mount, then paused. Jenkins, I need you to check my math here. If this anchor point fails, the whole system could cascade. Jenkins moved closer, studying her notebook where she had sketched the stress calculations. He traced the numbers with his finger. The carriage is rated for 12,000 pound towing capacity at this point. Your cable is pulling, he calculated silently, around 2,500 pounds under maximum recoil. That leaves a safety margin of almost 5 to 1. Torres nodded. Exactly, but I want a second set of eyes on it. Jenkins looked at her with something approaching respect. The math looks solid to me. They installed the anchor point and secured the 4th primary cable. Torres stepped back, surveying the web of steel that now surrounded the howitzer barrel. The secondary stabilizers came next, lighter cables positioned between the primary ones to dampen lateral movement. These were insurance, backup systems in case the primary cables experienced uneven loading. She worked faster now, muscle memory taking over as the pattern became clear. Dalton approached as she tightened the last secondary cable. Looks like a ship's rigging. Torres smiled slightly. Same engineering. Sailors figured out tension distribution 3,000 years ago. We were just applying it to a different problem. Dalton walked around the gun, examining each cable connection. His skepticism had not disappeared, but it had shifted into something more measured, more professional. If this fails during test fire, the barrel could separate from a carriage. Torres met his eyes. Yes, that is why I will be the only one in the gun pit for the first shot. Captain Rodriguez returned with 10 minutes remaining in the 2-hour window. He studied the improvised recoil system without speaking. The cables gleamed in the late afternoon sun, creating geometric patterns of shadow across the gun carriage. Finally he spoke. Explain the failure modes. What happens if a cable snaps? Torres pointed to the redundant cables. The secondary stabilizers take the load. The system might become less smooth, but it will not catastrophically fail. What if an anchor point shears? Then we have uneven load distribution. The gun will cant to one side, but the barrel will not separate. We would know immediately and cease fire. Rodriguez nodded slowly. Test fire protocol. Single training round. Minimum propellant charge. Maximum safe distance for all personnel except essential crew. Torres answered. And if it holds? Then we test with a combat load. And if that holds? Then we are back in action, sir. Rodriguez looked at Dalton. Your assessment, Sergeant? Dalton took a moment before responding. The engineering appears sound. I do not like field modifications, but I understand the necessity. If Sergeant Torres says it will work, I am willing to trust her expertise. It was the first time Dalton had publicly acknowledged her capability. Torres felt the weight of that trust settle on her shoulders. Rodriguez checked his watch. You have got your 2 hours, Torres. Let's see if theory holds up to reality. Load a training round. Minimum charge. Let's find out what this thing can do. Jenkins moved toward the ammunition storage. Martinez began clearing unnecessary equipment from the gun pit, and Torres positioned herself at the gun layer's seat, her hand resting on the cable she had spent 2 hours installing. In a few minutes, she would know if her calculations were correct, if the improvised recoil loop would hold, if she had earned the trust they were placing in her. The firebase grew quiet as word spread that the modified gun was about to fire. Jenkins loaded the training round while Torres checked each cable connection one final time. The training round contained only 30% of the propellant charge used in combat ammunition, but it would still generate enough recoil force to test whether the improvised system could function. Martinez stood at the minimum safe distance, 30 meters back from the gun pit. Dalton had ordered everyone except Torres and Jenkins to clear the area. If something went catastrophically wrong, there was no point in risking additional personnel. Torres settled into the gunner position. Her hands moved across the controls with practiced efficiency, elevating the barrel to the proper angle for test fire. The steel cables responded to the movement, flexing slightly as the gun shifted position. So far the system was holding under the static load. The real test would come when 8,000 pounds of recoil force slammed backward in a fraction of a second. Jenkins finished loading and stepped back. Round loaded, ready to fire. Torres could hear the tension in his voice. He moved toward the exit of the gun pit, then paused. Sergeant, you want me to stay? She shook her head. Get clear, Jenkins. If this fails, no reason for both of us to be here. He hesitated another moment, then jogged toward the safe area where the rest of the crew waited. Captain Rodriguez stood beside Dalton, both men watching through binoculars. Torres could feel their eyes on her. She took a breath and keyed the radio. Fire Direction Center, this is Gun 2, ready for test fire, training round, minimum charge. The radio crackled back. Gun 2, you are clear to fire when ready. She placed her hand on the firing mechanism. Her other hand rested on the cable tensioner, ready to feel any abnormal vibration or stress. The howitzer fired. The sound was sharp and flat, different from the deeper boom of a full combat load. Torres felt the recoil begin, the barrel driving backward as the round screamed downrange. The cables snapped taut with a sound like a whip crack. The entire web of steel vibrated violently, humming with absorbed energy. The gun carriage shifted backward 6 inches, exactly within tolerance. Then the cables flexed, the tension distributed across all the anchor points, and the barrel settled back into position. Smooth, controlled, functional. Torres exhaled and keyed the radio. Test fire complete, system held, no structural damage. She climbed out of the gunner's seat and examined the cables. They showed stress marks where they had absorbed the peak force, but no fraying, no weakness. The anchor points were solid. She walked around the gun twice, checking every connection point. Jenkins returned first, moving cautiously. It held. His voice carried disbelief and relief in equal measure. Martinez came next, running his hand along one of the primary cables. It is still warm from the friction. That is normal, Torres said. The cables convert kinetic energy to heat. That is part of how they absorb the force. As long as they do not exceed their thermal rating, we are fine. Dalton arrived with Captain Rodriguez. Both men circled the gun, inspecting the improvised recoil system from every angle. Dalton spoke first. No visible damage. Cables maintained integrity. Anchor points held. He looked at Torres. You were right about the redundancy. I saw the secondary cables flex when the primaries took the load. Good engineering. Torres nodded acknowledgement. Thank you, Sergeant. But we need a test with a combat load before we can declare this operational. That was 30% power. We need to see how it handles full force. Rodriguez studied the cable configuration. How long before you can test again? The cables need 15 minutes to cool and for me to check for any microstress fractures, Torres said. Then we load a combat round and see what happens. Rodriguez checked his watch. You have your 15 minutes. Make sure everything is perfect. This next test is the real one. Torres used the time to inspect every inch of cable and every bolt on every anchor point. She found one tensioner that had loosened slightly during the first test and tightened it back to specification. Jenkins brought her a bottle of water. You make this look easy. She drank, then set the bottle aside. It is not easy. It is just physics applied correctly. But physics does not care about confidence or nerves. The math works or it does not. Martinez touched one of the cables tentatively. Still warm, but cooling down. You really think it will hold at full power? Torres ran her fingers along the same cable, feeling the residual heat. The test fire proved the concept. The cables distributed the load exactly as calculated. A full combat round is 3 times the force, but we designed the system with a safety margin of 4-1. The math says it will hold. Martinez looked at her directly. But what do you say? She met his eyes. I say I am about to fire a combat round from this gun. That is my answer. Dalton had been listening. He stepped closer. Torres, nobody doubts you ran the numbers. But field conditions are not laboratory conditions. Variables you cannot predict. Unexpected stresses. If this system fails under combat load, we are back to a deadline gun and wasted time. She nodded. All true, which is why I'm going to be the only person in the gun pit again. If I am wrong, it is on me. The 15 minutes elapsed. Jenkins loaded a full combat round, high explosive, maximum propellant charge. The round weighed nearly 100 pounds. He secured it in the breech and cleared the pit quickly. Torres returned to the gunner position. This time the weight of the moment felt heavier. The cables that had seemed so strong during installation now looked thin and fragile against the massive steel barrel they were meant to restrain. She pushed the doubt aside and focused on the controls. Fire Direction Center, this is Gun 2, ready for combat load test fire. The radio response came immediately. Gun 2 cleared to fire when ready. Torres elevated the barrel to firing position. The cables hummed with tension. Her hand moved to the firing mechanism. Every calculation had to be correct. Every anchor point had to hold. Every assumption about material strength and stress distribution had to prove true. She pressed the firing button. The howitzer erupted. The recoil was massive. Torres felt it through the entire gun carriage as the barrel slammed backward with 3 times the force of the training round. The cables screamed under the load, vibrating so violently they became visible blurs of motion. The primary cables absorbed the initial shock, stretching slightly under peak stress. Then the secondary stabilizers engaged, dampening the lateral movement. The gun carriage rocked backward a full foot before the distributed tension across all 8 cables arrested the motion and brought the barrel smoothly back to position. Torres sat motionless for 3 seconds, processing what had just happened. The system had worked. Not just held together, but worked exactly as designed. She keyed the radio. Combat load test successful. System performed within parameters. No damage observed. She climbed out and immediately began inspecting the cables. Jenkins reached her first, breathing hard from sprinting to the gun pit. That was incredible. The cables just absorbed everything. Martinez arrived and placed his hand on one of the primary cables. It was hot to the touch, almost uncomfortable. Torres nodded. Thermal stress is higher than I calculated. We will need to let it cool between sustained fire missions. But structurally, everything held. She examined each anchor point carefully. 2 of the bolts showed slight scoring where the cables had pulled under maximum tension, but nothing that compromised integrity. Dalton and Rodriguez approached together. Dalton spoke first. I watched the entire recoil cycle. The system flexed exactly like you said it would. Distributed the force across multiple points. The barrel came back to battery perfectly. Rodriguez circled the gun slowly. How many rounds can it handle before the cables need replacement? Torres consulted her notebook. Conservative estimate, 200 rounds. The steel will work harden over time and eventually fatigue. But we can monitor cable condition visually. Any fraying or deformation, and we replace that cable immediately. Rodriguez studied the improvised recoil loop, then looked at Torres. Sergeant, I need to know if you are confident putting this gun into active service. Not test fire conditions. Real fire missions with enemy rounds incoming and Marines depending on our support. Can this system handle combat operations? Torres did not hesitate. Yes, sir. The test fire proved the engineering. The system will perform under combat conditions. Jenkins moved closer to examine the cable that had absorbed the most visible stress during the combat load test. This one looks like it's stretched slightly. Torres inspected the cable he indicated. Within tolerance. The cables are designed to have some give. That is how they absorb energy without breaking. Rigid components would shatter. Flexible components distribute and dissipate. Martinez asked the question everyone was thinking. So when do we put to work? Rodriguez answered. Right now, we have a fire mission waiting. Enemy position identified 6 kilometers northeast. Torres, get your crew ready. This gun is back in action. He walked away to coordinate with Fire Direction Center. Dalton remained behind. He looked at the cables, then at Torres. I doubted this would work. I was wrong. She met his eyes. You had good reasons to doubt. Field modifications are risky, but sometimes risk is necessary. The fire mission came through 2 minutes later. Enemy mortar team operating from a ridgeline. Coordinates provided by forward observers. 3 rounds, high explosive, fire for effect. Torres took her position at the gun controls. Jenkins and Martinez moved through the loading sequence with practiced efficiency. First round loaded. Torres verified the firing solution and elevated the barrel. The cables shifted with the movement, already warm from the test fire, but still functional. She fired. The howitzer roared and the recoil loop system engaged again. The cables snapped taut, vibrating with absorbed energy. The barrel recoiled, the tension distributed perfectly across all anchor points, and the gun settled back into position. Round away, Torres reported. Jenkins was already loading the second round. The rhythm of combat operations took over, muscle memory and training overriding any nervousness about the improvised system. Second round fired. The cables performed identically, flexing and absorbing the force. Torres noticed the primary cables were slightly hotter now, the repeated thermal stress beginning to accumulate. Still within safe limits, but approaching the threshold where they would need cooling time. Third round loaded and ready. She adjusted the elevation slightly based on spotter feedback. Final round fired. The recoil loop held perfectly. 3 rounds delivered on target without any system degradation. Fire Direction Center confirmed direct hits. Enemy mortar position neutralized. Torres climbed out of the gunner's seat and immediately checked the cables. They were hot now, too hot to touch comfortably. She noted the thermal reading in her notebook. We need 15 minutes cooling time between 3-round fire missions. If we push it harder, the cables could exceed their thermal rating and weaken. Dalton nodded. Understood. I will coordinate with Fire Direction Center to space out missions accordingly. Other artillery crews began gathering around Gun 2 to examine the improvised recoil system. Sergeant Chun from Gun 3 touched one of the cables carefully. This is field expedient engineering at its finest. How did you know the exact anchor points? Torres pointed to the stress calculations in her notebook. Load distribution requires precise geometry. Each cable has to pull at a specific angle to balance the forces. Too steep, and you get uneven loading. Too shallow, and you lose mechanical advantage. Staff Sergeant Williams from Gun 4 studied the configuration from multiple angles. The brass is going to want documentation on this. If it works here, other units might need to implement the same fix. Torres had already considered that. I have been photographing each step and recording specifications. If this becomes a field manual procedure, we will have everything documented. Captain Rodriguez will need to submit it through proper channels. Martinez interrupted. Sergeant Torres, We have another fire mission incoming. Torres checked her watch. The cables had been cooling for 12 minutes. Close enough. She moved back to the gunner position. What are the targets? Martinez read from the fire mission order. Enemy fighting position, fortified structure for 1,000 meters. 6 rounds requested. Torres calculated quickly. 6 rounds will generate significant thermal load. We will need to monitor cable temperature closely and potentially pause if we see any degradation. Jenkins began loading the first round. Dalton positioned himself where he could observe both the gun operation and the cable system. Rodriguez watched from the command post, binoculars trained on Gun 2. The entire firebase had become aware that the modified howitzer was back in action. Torres fired the first round. The cables performed flawlessly. Second round, still good. Third round, thermal stress increasing but within limits. Fourth round, she noticed one of the secondary stabilizer cables vibrating differently than the others. Fifth round, the anomaly in the cable vibration became more pronounced. She held up her hand before Jenkins could load the 6th round. Cease loading. Torres climbed out and moved to the secondary stabilizer, showing abnormal behavior. The cable had developed a slight kink where it passed through a guide ring. Not dangerous yet, but the beginning of a potential failure point. She loosened the tensioner, straightened the cable, and retightened to proper specification. The fix took 90 seconds. Problem solved. Load the 6th round. Jenkins slammed the final round home. Torres fired. The recoil loop system absorbed the force perfectly, the repaired cable performing normally. 6 rounds complete, all on target, system operational. The sun dropped below the mountains as Torres completed her 3rd inspection of the cable system. Gun 2 had fired 28 rounds since going operational, more than any other howitzer in the firebase that day. The improvised recoil loop had performed without failure, but the accumulated thermal stress was beginning to show. 2 of the primary cables showed minor surface where they rubbed against the guide rings during recoil cycles. Nothing critical yet, but Torres made detailed notes for monitoring. Jenkins approached with evening chow. You need to eat something, Sergeant. You have been at this for 8 hours straight. Torres accepted the meal without taking her eyes off the cable she was examining. 8 hours and 28 rounds. The system is holding better than I projected. She ran her finger along a section of cable that showed slight discoloration from heat. We will need to replace this cable tomorrow. It is still functional, but showing early fatigue signs. Martinez joined them, carrying his own tray. I heard Gun 4 had a hydraulic leak today. Took them offline for 3 hours. Meanwhile, our busted gun, with the improvised fix, has not missed a single fire mission. Torres smiled slightly. The recoil loop is not busted. It is adapted. There's a difference. Dalton walked up as she spoke. He had been coordinating with Fire Direction Center for the past hour. Captain wants to see you, Torres. He is in the command post. She set down her food and followed Dalton across the firebase. The command post was a fortified bunker half buried in the hillside. Captain Rodriguez stood over a map table, red circles marking enemy positions identified throughout the day. He looked up as Torres entered. Sergeant Torres, sit down. She remained standing. Respectfully, sir, I would rather stand. I've been sitting in that gun pit all day. Rodriguez gestured to the map. Fire Direction Center processed 42 fire missions today. Gun 2 handled 12 of them. That is more than any other asset we have. Your improvised recoil system has proven itself under combat conditions. I am recommending you for recognition. Torres felt uncomfortable with the praise. Sir, I just applied basic engineering principles. Any competent crew chief could have done the same thing. Rodriguez shook his head. No, Torres. Any crew chief could have looked at that broken gun and waited for parts. You looked at it and saw a solution. That is the difference between following procedures and adapting to circumstances. Battalion wants full documentation of your recoil loop system. Apparently, other firebases are watching our results with interest. She nodded. I have photographs and specifications ready for review. The system is not complicated once you understand the load distribution principles. What is the long-term sustainability? Rodriguez asked. How long can we operate with this improvised fix? Torres considered the question carefully. With proper cable rotation and thermal management, indefinitely. The primary cables will need replacement every 200 rounds approximately. Secondary stabilizers can go longer. As long as we have cable and anchor hardware, we can maintain the system. It is not ideal, but it is functional. Rodriguez marked something on his map. Good, because supply chain says we will not see replacement hydraulic buffers for at least 3 weeks. Your recoil loop just became our primary solution, not a temporary fix. Torres absorbed that information. Understood, sir. I will establish a maintenance schedule and train the crew on cable inspection procedures. Rodriguez dismissed her, and she walked back to Gun 2. The fire base settled into evening routine. Crews rotated through watch shifts. Martinez was pulling first watch on Gun 2. Torres found him checking the cable tensions with a torque wrench. He had been watching her maintenance procedures and learning. Good initiative, Torres said. What are you finding? Martinez consulted his notes. Tension on cables 1 and 3 dropped by 5% since this afternoon. I adjusted them back to specification. Cable 2 and 4 are still dead on. Torres verified his work with her own torque wrench. Perfect adjustment. You're learning fast. Martinez looked at the improvised recoil system with something approaching pride. I was wrong about you. I figured the captain was just humoring you when he approved the test fire. I did not think it would actually work. Torres checked another cable. Most people did not think it would work. That is fine. I was not trying to prove anything to anyone except myself. Jenkins arrived to relieve Martinez. He carried a small camera. Captain Rodriguez wants more documentation photos for his report to battalion. You mind if I photograph the cable configuration from different angles? Torres stepped back. Go ahead. Make sure you get clear shots of the anchor points and cable routing. Those are the critical elements. Anyone else would need to replicate this. Jenkins moved around the gun methodically, capturing each aspect of the improvised system. Dalton appeared carrying a clipboard. Torres, I need you to review the maintenance schedule I drafted. She took the clipboard and read through his proposed procedures. Cable inspection every 50 rounds. Tension verification every 25 rounds. Thermal imaging after sustained fire missions. It was thorough and well considered. This is good, Sergeant. You included contingencies I had not thought about. Dalton nodded. I might have doubted the system initially, but now that it is operational, I want to make sure we maintain it correctly. A radio call interrupted them. Fire mission, priority target, enemy vehicle convoy, 8 kilometers northeast. Torres, checker watch. The cables had cooled for 90 minutes since the last fire mission. She moved to the gunner position. How many rounds? Dalton read from the fire order. 10 rounds, high explosive, sustained fire. Torres calculated quickly. 10 rounds will push our thermal limits. We will need to monitor closely and possibly pause if temperatures exceed safe thresholds. Jenkins loaded the first round. Martinez positioned himself to observe cable temperature with a handheld infrared thermometer. Dalton coordinated with Fire Direction Center. Torres fired the first round. The recoil loop engaged smoothly. Second round. Cables heating, but within limits. Third round. Temperature climbing. Fourth round. Martinez called out the thermal reading. Cables at 60% of maximum rated temperature. Fifth round. Torres adjusted her firing rhythm slightly, adding a few extra seconds between rounds to allow marginal cooling. Sixth round. 70% of maximum temperature. Seventh round. 75%. Martinez watched his thermometer closely. We are approaching the threshold, Sergeant. Torres nodded. 2 more rounds, then we pause for cooling. 8th round fired. 9th round. 80% of maximum rated temperature. She held up her hand. Ceasefire. Cooling pause, 5 minutes. Jenkins stepped back from the breach. Dalton radioed Fire Direction Center. Gun 2 pausing for thermal management. Will resume in 5 minutes. The 5 minutes felt longer than they were. Torres watched the cables gradually dissipate heat into the evening air. Martinez monitored the temperature drop. 65%, 60%, 55%. After 5 minutes, the cables had cooled to 50% of maximum rating. Safe to continue. Torres keyed the radio. Gun 2 ready to resume. Jenkins loaded the 10th and final round. She fired. The cable system performed perfectly, absorbing the recoil and settling the gun back into position. Fire mission complete, all rounds on target. Rodriguez's voice came over the radio. Gun 2, excellent work. Enemy convoy destroyed. Battalion commander sends his compliments. Torres acknowledged and climbed out of the gun pit. She inspected the cables immediately. They showed no new damage despite the thermal stress. The system had proven itself again. Dalton approached. That was textbook thermal management. You knew exactly when to pause. Torres secured her notebook. The math told me when to pause. I just listened to what the numbers were saying. Sometimes the hardest part is trusting your own calculations. Day 3 of operations with a recoil loop system brought new challenges. Torres arrived at Gun 2 before dawn to find one of the primary cables showing significant wear at the anchor point. The steel strands had begun to fray where the cable passed through the guide ring during repeated recoil cycles. She photographed the damage and made detailed notes. This cable had absorbed peak stress on 74 fire missions. Time for replacement. Jenkins helped her remove the worn cable and install a fresh one from their reserve stock. The replacement process took 40 minutes, longer than Torres wanted, but necessary to maintain system integrity. As they worked, Sergeant Shin from Gun 3 watched closely. My gun developed a hydraulic leak last night. Nothing as catastrophic as yours, but I'm starting to think about backup options. How difficult is it to implement your recoil loop system? Torres tightened the final anchor bolt on the new cable. The math is straightforward if you understand load distribution. The execution requires precision. Every cable has to be positioned at the exact angle, or the forces do not balance properly. Shin nodded slowly. Could you walk my crew through it, just in case we need to implement it ourselves? Torres glanced at Dalton, who had arrived during the conversation. Dalton considered for a moment, then nodded approval. Sergeant Torres, conduct a training session for Gun 3 and Gun 4 crews. If we can cross-train on this system, we increase our operational resilience. The training session assembled 12 soldiers around Gun 2 at mid-morning. Torres explained the engineering principles first, using diagrams to show how tension cables could replace hydraulic buffers. Some of the soldiers looked skeptical. Staff Sergeant Williams from Gun 4 raised his hand. This seems like something that works in theory, but fails under real stress. How do we know it will not catastrophically fail during a critical fire mission? Torres pointed to the cable configuration. We know because it has already fired 106 rounds without failure. The system has been tested under sustained fire, rapid fire, and maximum propellant loads. Every potential failure mode has been stress tested. Williams crossed his arms. 106 rounds is not that many. Our guns fire that many in a week during heavy operations. What happens at 500 rounds? 1,000? Fair question, Torres acknowledged. We do not have long-term data yet, but we do have maintenance protocols. Regular cable inspection, scheduled replacement, thermal management. The hydraulic buffers you are currently using also require maintenance and eventually fail. This system is no different. It just uses different engineering principles to achieve the same result. She walked them through cable routing, anchor point selection, and tension calculations. Several soldiers took notes. Others remained visibly doubtful. A radio call interrupted the training. Priority fire mission, enemy artillery position identified. Immediate suppression required. Torres dismissed the training group and moved to Gun 2. How many rounds? Dalton checked the fire order. 15 rounds, maximum rate of fire, no delay between rounds. Torres felt her stomach tighten. 15 rounds at maximum rate would generate extreme thermal stress. The cables had never been tested under those conditions. We're going to push the thermal limits hard. I need continuous temperature monitoring. Martinez positioned himself with the infrared thermometer. Jenkins began loading rounds in rapid succession. Dalton coordinated with Fire Direction Center while watching Torres closely. She could see the concern in his expression. If the cables failed during sustained fire, the barrel could separate. You sure about this? Torres settled into the gunner position. The math says the system can handle it. Let's find out if the math is right. She fired the first round. The recoil loop engaged. Second round, 3 seconds later. Third round, the cables were already warming perceptibly. Fourth round, Martinez called out temperatures. 40% of max rating. Fifth round, 50%. Sixth round, 60%. The firing rhythm was relentless. No time for cooling between rounds. Seventh round, 70%. Torres could see heat waves rising from the cables now. Eighth round, 75%. Martinez's voice carried tension. We are exceeding our previous maximum. Torres kept firing. Ninth round, 80%. 10th round, 85%. The cables were vibrating differently now, the heat affecting their mechanical properties. 11th round, 90%. Dalton stepped closer. Torres, we are in uncharted territory. She fired the 12th round. 92% of maximum rated temperature. The cables glowed faintly in the morning light. 13th round, 95%. Martinez was watching his thermometer like it might explode. Sergeant, we are at the edge of the safe envelope. Torres fired the 14th round. 97%. 1 round remaining. She could abort, let the cables cool, resume fire later. But the fire mission required immediate suppression. Enemy artillery was active, threatening Marine positions. She loaded the 15th and final round. The cables were beyond any temperature they had previously endured. She fired. The recoil was identical to the previous 14 rounds. The cables screamed under the thermal load but held their integrity. The barrel recoiled, the tension distributed across all anchor points, and the gun settled back perfectly into battery. 15 rounds complete. Torres exhaled and immediately climbed out to inspect the cables. They were too hot to approach closely. Heat radiated from the steel in visible waves. But visually they showed no damage, no fraying, no deformation. Martinez checked his thermometer. 98% of maximum rated temperature. That was as close as I ever want to get. Fire Direction Center confirmed all 15 rounds had hit their target. Enemy artillery position destroyed. Captain Rodriguez arrived as the cables began cooling. I heard you push the thermal envelope to near maximum. His tone was neutral, neither critical nor congratulatory. Torres nodded. 15 rounds at maximum rate required it, sir. The system performed within acceptable limits. Rodriguez studied the still hot cables. Barely within limits. What if we had needed 16 rounds? Torres met his eyes. Then we would have exceeded thermal rating and risked cable failure. I would have had a pause for cooling regardless of a tactical situation. Rodriguez considered that. So the system has limits. Torres nodded. Every system has limits, sir. The hydraulic buffers we normally use also have rate-off fire restrictions. The recoil loop is no different. It just has different constraints. Dalton joined them. The question is whether those constraints are acceptable for combat operations. Torres pointed her notebook. We now know the system can handle 15 rounds at maximum rate before requiring cooling. That is actually better than I calculated. The safety margin I built into the cable specifications performed exactly as designed. For normal operations, this system is more than adequate. Staff Sergeant Williams from the training session had been watching the entire fire mission. He approached Torres. I need to apologize. I questioned whether this would hold up under real stress. You just proved it will. Can we resume the training session? I want my crew to know how to implement this system. Torres, check her watch. Give me 30 minutes for these cables to cool and for me to verify no damage. Then we continue training. The cables cooled slowly. Torres used the time to document the thermal performance in her notebook. 15 rounds at maximum rate. Peak temperature 98% of rating, 0 failures, 0 damage. The data would be valuable for other units implementing the system. Jenkins approached with water. That was the most intense fire mission we have run. You never hesitated. Torres drank. I hesitated internally. But the mission required those rounds, and the math said the cables would hold. Sometimes you have to trust your engineering, even when it feels risky. Martinez was inspecting the cables that had just endured the thermal stress test. They looked perfect, no damage at all. How did you know they would hold? Torres joined him at the gun. I did not know. I calculated the probability based on material science and thermodynamics. High probability, but not certainty. That is the difference between engineering and gambling. Engineering stacks the odds in your favor, but there is always uncertainty. Dalton called the training group back together. Sergeant Torres has just demonstrated the upper limits of this system under combat conditions. Pay attention to her lessons. This knowledge might save your gun and your fire mission someday. Torres resumed the training, walking the crews through every detail of cable selection, routing, tension management, and thermal monitoring. By the time the session ended, 3 crews understood how to implement the recoil loop system if needed. The improvised fix was becoming standardized procedure. By day 5, Gun 2 had become the most reliable artillery piece in the firebase. The other howitzers experienced intermittent hydraulic issues, maintenance delays, and parts shortages. Torres's improvised recoil loop system required only cable inspection and occasional replacement, materials that were readily available from supply. The firebase had fired over 300 rounds through Gun 2 without a single mission failure. Battalion headquarters sent a technical team to document the system for potential fleet-wide implementation. A warrant officer named Briggs arrived with cameras and measuring equipment. He spent 2 hours photographing every angle, measuring every dimension, and interviewing Torres about the engineering principles. This is remarkable field engineering, Briggs said. How did you develop the load distribution calculations without computer modeling? Torres showed him her notebook filled with hand-drawn diagrams and equations. Basic structural engineering. The same math that designs bridges and cranes. I just applied it to a different problem. Briggs flipped through the pages. These calculations are graduate-level work. Where did you study? Torres hesitated, then answered. Mit Mechanical Engineering Programme. 2 years before I enlisted. Briggs looked up sharply. You left MIT to join the Army? Torres closed the notebook. I have my reasons. Briggs did not press further. He finished his documentation and departed with enough information to write a technical manual. Captain Rodriguez told Torres that afternoon that battalion wanted her to brief the system to other firebase commanders via video conference the following week. The recoil loop was officially becoming doctrine. That evening brought a new challenge. Jenkins reported that one of the secondary stabilizer cables had developed a stress fracture near the anchor point. The fracture was small, barely visible, but Torres knew it would propagate under continued use. We need to replace this cable before the next fire mission. Martinez retrieved a replacement from their cable stock. As they worked, Dalton approached with a radio message. Torres, we have a situation developing. Enemy forces are massing for what intelligence thinks is a major assault tomorrow morning. Battalion expects heavy contact. How heavy? Torres asked while removing the damaged cable. Dalton consulted his notes. Potentially the largest engagement we have seen in 3 months. Every gun will be firing at maximum sustainable rate for extended periods. Torres and Martinez exchanged glances. Extended maximum rate would push every system to its limits, especially the improvised recoil loop. She installed the fresh cable with extra attention to tension specifications. If we're going into sustained operations tomorrow, I want to inspect every cable on this gun tonight. The inspection took 3 hours. Torres found 2 more cables showing early wear signs and replaced them proactively. By midnight, Gun 2 was as prepared as engineering and available materials could make it. She tried to sleep but found herself mentally reviewing stress calculations and failure modes. Jenkins found her at 0200 sitting beside the gun with her notebook and flashlight. You should be resting, Sergeant. Big day tomorrow. Torres looked up. Cannot rest when I am running scenarios in my head. What if we need to fire 30 rounds sustained? What if thermal conditions exceed anything we have tested? Jenkins sat down beside her. You have tested this system harder than anyone thought possible. It has never failed. Not once. Torres nodded, but the doubt remained. Every previous test had an endpoint. A specific number of rounds, then cooling time. Tomorrow there might not be time for cooling. We might have to fire until the cables fail or the battle ends, whichever comes first. Jenkins was quiet for a moment. Then we trust your engineering. The math has been right every time so far. Dawn came with unusual quiet. The firebase waited. Marines checked weapons and equipment. Artillery crews prepared ammunition. Torres conducted one final inspection of the recoil loop system. Every cable was at proper tension. Every anchor point was secure. Dalton gathered the gun crews for a brief. Intelligence expects enemy contact within 2 hours. When it starts, we fire until we run out of targets or ammunition. Thermal management protocols remain in effect, but mission requirements take priority over equipment preservation. Everyone understand? The crews acknowledged. Torres felt the weight of that final statement. Mission requirements take priority over equipment preservation. Translation: push the systems until they break if necessary. Dalton looked directly at her. Torres, your gun has proven most reliable. You will likely handle the heaviest fire missions today. She nodded. Understood, Sergeant. Gun 2 is ready. Martinez and Jenkins took their positions. The firebase settled into tense anticipation. The radio crackled at 0647. Contact. Enemy forces advancing on southern perimeter. All guns prepare for fire missions. Torres moved to the gunner position. This was it. The real test of everything she had engineered. Not controlled test fires or even combat missions with cooling breaks. This would be sustained maximum rate fire until the battle concluded. Jenkins loaded the first round. Fire mission data came through. Enemy infantry concentration for 1,000 meters. 10 rounds. Fire for effect. She fired the first round. The recoil loop engaged smoothly. Second round, 3 seconds later. Third round. The rhythm was immediate and relentless. Fourth round. Martinez called temperature readings. Fifth round. Rising quickly due to rapid fire. Sixth round. 40% thermal rating. Seventh round. Eighth round. 55%. Ninth round. 10th round complete. 60% thermal load already. No time to cool. Next fire mission came immediately. Enemy mortar position, 6,000 meters, 8 rounds. Torres adjusted the gun and fired continuously. Round after round, the cables climbed toward 70% thermal rating. Jenkins and Martinez moved like machines, loading and monitoring without pause. Dalton coordinated fire missions while watching the cable system carefully. Third fire mission, Anemi Baiklas, 15 rounds. Torres glanced at the cables. They were hot now, heat distortion visible in the air around them. Martinez called 80% thermal rating. The fire missions kept coming. Fourth mission, fifth mission. The battle had fully developed. Enemy forces were hitting the firebase from multiple directions. Every artillery piece was firing at maximum rate. Gun 3 developed a hydraulic leak and went offline. Gun 4 had a breech malfunction that took 20 minutes to clear. Gun 2 kept firing. Sixth mission. Seventh mission. The cables reached 85% thermal rating. Torres could feel the heat radiating from them even inside the gun pit. Eighth fire mission. Priority target. Enemy command post identified. 20 rounds required. Martinez's voice was tight. Sergeant, we are at 88% thermal. 20 more rounds will take us past anything we have tested. Torres checked the target coordinates. Command post was coordinating the entire enemy assault. Taking it out could break their attack. She keyed the radio. Gun 2 commencing fire on priority target. Dalton's voice came back. Torres, you're authorized to pause for cooling if necessary. She considered the tactical situation. Marines were engaged across the entire perimeter. The enemy command post was the linchpin of their assault. 20 rounds to destroy it. She made her decision. Negative, continuing fire mission without pause. Jenkins loaded the first round. Torres fired. The cables absorbed the recoil. Second round. Third round. 90% thermal rating. The heat was intense now. Fourth round. Fifth round. 92%. The cables vibrated differently at this temperature, their mechanical properties altered by the thermal stress. She kept firing. 10th round. 95% thermal rating. Martinez was watching his thermometer like it held his life. Halfway through the fire mission. 10 rounds remaining. Torres fired the 11th round. The cable system screamed under the load but held. 12th round. 13th round. 97%. The cables were beyond any sustained temperature they had previously endured. 3 seconds between rounds, no pause, no cooling. 14th round. 15th round. 98%. Torres could smell the hot metal. 16th round. 98.5%. Martinez's voice cracked. We are exceeding maximum rating. Torres fired the 17th round. One of the cables made a sound like a guitar string about to snap. Jenkins hesitated, loading the 18th round. Torres, that cable. She saw it too. The primary cable on the left side was vibrating at a frequency that suggested imminent failure. 2 rounds remaining. Enemy command post almost destroyed. She made the calculation instantly. Fire the mission, risk the cable. Abort. Leave the target intact. Jenkins, load. He loaded. She fired the 18th round. The cable held. 19th round loaded. Final round. 99% thermal rating. The cable system was at the absolute edge of failure. Torres fired. The recoil loop engaged one more time. The cables flexed, absorbed the energy, and brought the barrel back to position. 20 rounds complete. Fire direction center confirmed, direct hits. Enemy command post destroyed. Torres climbed out immediately to inspect the cables. The left primary cable showed visible stress damage. It would need replacement before the next fire mission. But it had held. Barely, but it had held. Torres replaced the stressed cable in 4 minutes, working with speed born of repetition and necessity. The battle continued around her. Small arms fire echoed from the perimeter. Mortars impacted sporadically. Gun 4 was back online, but Gun 3 remained deadlined with hydraulic failure. The fire-based defense was holding, but barely. Martinez handed her the new cable. How many more missions can we run before we need extended cooling? Torres tightened the anchor bolt. We just pushed to 99% thermal. The cables need at least 10 minutes to drop below 80% before we can safely resume sustained fire. But something in her gut told her they would not get 10 minutes. Dalton confirmed it seconds later. Torres, enemy forces regrouping for second wave. Intelligence estimates 15 minutes before contact. We need all guns ready. She secured the final connection. Gun 2 operational. Ready for fire missions. Jenkins had been counting ammunition. We have fired 147 rounds since dawn. Supply says we have approximately 300 rounds remaining in our immediate stock. If this second wave is as heavy as the first, we might run dry. Torres did the mental calculation. 300 rounds spread across multiple fire missions, maximum rate. The cables would experience thermal stress beyond anything previously tested. She looked at the crew. Martinez, I need you on thermal monitoring constantly. Any reading above 99%, and you tell me immediately. Jenkins, load as fast as you safely can, but do not sacrifice procedure for speed. Understood? Both men nodded. Captain Rodriguez arrived at the gun pit. His uniform was covered in dust from a near miss during the first wave. Torres, battalion commander, wants gun 2 designated priority fire asset. That means every critical fire mission comes to you first. Your gun has proven most reliable under sustained fire. Can you continue to deliver? Torres met his eyes. Yes, sir. The system will hold. Rodriguez nodded. I'm counting on that. Every Marine on this fire base is counting on that. The second wave hit at 0734. Enemy forces in greater numbers than the first assault. The radio exploded with fire mission requests. Gun 2, enemy infantry advancing southern perimeter, 25 rounds. Torres elevated the barrel and began firing. The cables were still warm from the previous missions, starting at 65% thermal rating. Each round pushed them higher. Martinez called readings continuously. 70%, 75%, 80%. The 25-round mission completed. Cables at 87%. No cooling time. Next mission immediately. Enemy machine gun positions, 12 rounds. Torres fired without pause. 90% thermal. 92%. The cables were running hot now. Heat visible in waves around the steel. Mission complete. 94%. Third mission. Enemy mortar teams, 18 rounds. Martinez's voice was strained. We are entering critical thermal range. Torres kept firing. She could feel the cables protesting, the vibration through the gun carriage different at these temperatures. 96%. 97%. 18 rounds complete. 98% thermal rating. Dalton was coordinating with Fire Direction Center. They were throwing every available fire mission at Gun 2 because the other guns could not maintain the pace. Gun 4 had a stoppage. Gun 1 was rotating crews due to heat exhaustion. Gun 2 kept firing. Fourth mission. Fifth mission. The cable stayed pegged at 98%, unable to cool between missions. Torres felt sweat running down her back, despite the morning temperature. Jenkins loaded rounds mechanically. Martinez never stopped calling thermal readings. Sixth mission was the critical one. Enemy assault element. Main force concentration. Coordinates indicated they were preparing to breach the firebase perimeter. 40 rounds required. Stop them, or the firebase would be overrun. Torres received the fire mission and felt ice in her stomach. 40 rounds sustained at 98% thermal. The cables might not survive. Dalton seemed to read her thoughts. Torres, can the system handle it? She calculated quickly. 40 rounds would generate thermal accumulation beyond any tested parameter. The cables were already at maximum safe temperature. Adding 40 more rounds of thermal load could cause catastrophic failure. But the alternative was enemy forces breaching the perimeter. She made her decision. Gun 2 commencing fire on main assault element. Martinez, monitor for any sign of cable degradation. If you see anything abnormal, call ceasefire immediately. First round fired. Second round. Third round. The cables held at 98%, the heat having reached an equilibrium where they dissipated thermal energy as fast as they accumulated it. Fourth round. Fifth round. The rhythm was relentless. Jenkins was loading faster than Torres had ever seen. Sixth round. Seventh round. Martinez called a reading. 98.3%. Slight increase. Torres noted it but continued firing. Eighth round. Ninth round. 10th round. Staff Sergeant Williams from Gun 4 had come over to observe. He watched the cable system with obvious concern. Those cables are beyond any safe operating temperature. Torres fired the 11th round. I know. Williams shook his head. If they fail, the barrel could separate from the carriage. 1,200 pounds of steel barrel flying free. Torres fired the 12th round. I know that too. Williams stayed, unable to look away from what he was witnessing. 15th round. 20th round. 98.5% thermal. Martinez's voice was tight. We were climbing slowly. Torres could see it too. The cables could not quite dissipate heat fast enough at this rate of fire. Every few rounds the temperature crept up fractionally. 25th round. 98.6%. 30 rounds remaining in the mission. She adjusted her firing rhythm slightly, adding half a second between rounds. Not enough to significantly slow the mission, but enough to give fractionally more cooling time. 30th round. 98.7%. The cable system was in uncharted territory. Jenkins' voice broke the concentration. 10 rounds remaining. Torres could see the finish line. 10 more rounds, and the enemy main assault would be shattered. She fired the 31st round. 32nd round. 98.8%. One of the secondary stabilizer cables began making a high-pitched vibration sound. Martinez saw it simultaneously. Secondary cable 3 showing stress signs. Torres evaluated instantly. Secondary cables were backup systems. If one failed, the primary cables would compensate. She continued firing. 33rd round. 34th round. The vibrating cable's pitch increased. 35th round. Dalton had moved closer, watching the stressed cable. Torres, that cable is going to fail. She fired the 36th round. Let fail. The primaries will hold. 37th round. The secondary cable snapped with a sharp crack. The gun rocked slightly as the load redistributed to remaining cables. Primary cables compensated immediately. System still functional. 38th round. 39th round. 98.9% thermal rating. The primary cables were absorbing the extra load from the failed secondary. 2 rounds remaining. Torres fired the 40th round and final round in rapid succession. Mission complete. She climbed out immediately to inspect the damage. The failed secondary cable hung loose, its severed end showing the stress fracture that had propagated to failure. But the 4 primary cables remained intact, still holding the gun together despite being pushed beyond any reasonable limit. Fire Direction Center confirmed the results. Enemy main assault element destroyed. Enemy forces withdrawing. The second wave had broken against the firebase defenses. Torres looked at the cable system she had engineered 5 days ago. 1 secondary cable failed, but the redundancy built into the design had saved the mission. The mathematics of load distribution had proven accurate even under conditions that exceeded every test parameter. Martinez checked his thermometer. Cable's cooling now, down to 96%. Jenkins collapsed against the gun carriage. 187 rounds fired today. System held. Captain Rodriguez returned. Torres, battalion commander, is on the radio. Want to speak with you personally. She followed him to the command post. The battalion commander's voice came through clearly. Sergeant Torres, your gun delivered fire support that was decisive in holding this firebase. I am recommending you for the Bronze Star with Valor device. Your engineering and leadership under fire saved lives today. Torres felt the weight of those words. She thought about the 5 days of doubt, the skepticism, the moment in Chapter 1 when Dalton had dismissed her assessment as theories. The cables had proven it was mathematics, not theories. Engineering, not luck. She keyed the radio. Thank you, sir. Just did my job. The battalion commander signed off. Torres walked back to Gun 2, where her crew was replacing the failed secondary cable. The improvised recoil loop had passed the ultimate test. The Firebase command post filled with personnel as Torres prepared her formal brief on the recoil loop system. Battalion Commander Lieutenant Colonel Morrison had arrived by helicopter specifically to observe Gun 2 and receive a detailed technical explanation. He stood beside Captain Rodriguez, both studying the cable configuration that had just fired 187 rounds during the most intense battle the Firebase had experienced. Morrison circled the gun slowly, examining each anchor point and cable routing. This is the improvised system that held the southern perimeter? Torres stepped forward. Yes, sir. Improvised recoil dampening using tension cable load distribution to replace the failed hydraulic buffer system. Morrison touched one of the primary cables. It was still warm hours after the battle. How did you calculate the load-bearing requirements without computer modeling or engineering software? Torres opened her notebook. Basic structural engineering mathematics, sir. The same principles used in bridge suspension systems and crane rigging. Force vectors, tension distribution, material stress tolerances. I calculated by hand and verified against known material specifications. Morrison flipped through her notebook, pausing on pages dense with equations and diagrams. This is MIT-level engineering work. Torres nodded. I completed 2 years at MIT Mechanical Engineering before enlisting, sir. Morrison looked up sharply. Why would someone leave MIT to join the Army? Torres met his eyes. Personal reasons, sir. Morrison did not press further, but his expression showed respect. He turned to the assembled personnel. I want everyone here to understand what Sergeant Torres accomplished. She took a catastrophic equipment failure and engineered a field solution that outperformed our standard systems under combat conditions. That is exceptional problem-solving under pressure. Dalton stepped forward. Sir, if I may, when Sergeant Torres first proposed this system, I doubted it would work. I thought we should deadline the gun and wait for proper parts. She proved me wrong. The recoil loop performed flawlessly through sustained combat operations that would have stressed even a fully functional hydraulic system. Morrison nodded. Sergeant First Class Dalton, there is no shame in initial skepticism. The value is in recognizing when you are wrong and adapting. That speaks well of your leadership. Jenkins raised his hand. Sir, permission to speak? Morrison gestured approval. Sergeant Torres could have taken the easy path and let someone else handle the problem. Instead, she took personal risk by testing the system herself first. When we needed to fire 40 rounds at maximum thermal load during the second wave, she made the call to continue despite cable stress. That decision saved the firebase. Morrison looked at Torres. You fired 40 rounds with the system already at maximum temperature? Torres confirmed. Yes, sir. The tactical situation required it. We had one secondary cable fail during the mission, but the primary cables held. The redundancy I built into the design performed as calculated. Morrison walked to the gun and examined the replaced secondary cable hanging on the maintenance rack. You designed redundancy into an improvised field repair? Torres nodded. Every engineering system should account for component failure, sir. The 4 primary cables could handle the full load if necessary. The secondary stabilizers provided additional margin and dampened lateral forces. Losing one secondary reduced performance slightly, but did not compromise structural integrity. Morrison studied the failed cable closely. The fracture points showed classic fatigue failure under thermal and mechanical stress. Staff Sergeant Williams spoke up. Sir, I questioned whether this system could handle sustained fire. I watched Gun 2 fire that 40-round mission at 98% thermal load. The engineering was perfect. When that secondary cable snapped, I thought the whole system would cascade into failure. Instead, the primary cables just absorbed the extra load like Sergeant Torres said they would. The math was exact. Morrison turned to Torres. You calculated the failure modes before they occurred? Torres pointed her notebook. Every potential failure has a predictable pattern based on material science and stress dynamics. I knew which cables would fail first under extreme conditions. I knew how the remaining cables would redistribute the load. That is not luck or intuition, sir. That is engineering. Morrison smiled slightly. Sergeant Torres, I'm going to be direct with you. The Army needs more problem solvers like you. Have you considered officer candidate school? Your engineering background and demonstrated leadership make you an ideal candidate. Torres was caught off guard. I had not considered it, sir. Morrison handed her notebook back. Think about it. In the meantime, I am authorizing immediate documentation of your recoil loop system for inclusion in field maintenance manuals. Every artillery unit in theater needs to know this procedure. You are also being assigned to brief this system to the division artillery commander next week. Questions? Torres had none. Morrison turned to address everyone assembled. What we witnessed today is why we train soldiers to think, not just follow procedures. Sergeant Torres saw a broken gun and found a solution. That adaptability wins battles. The brief concluded and Morrison departed. The firebase settled into post-battle routine. Torres conducted a complete inspection of Gun 2 with Martinez and Jenkins. Every cable was removed, examined under magnification for stress fractures, and either approved for continued use or replaced. The process took 4 hours. By evening, Gun 2 was restored to full operational status with fresh cables and documented maintenance. Dalton approached as she finished. Torres, word is spreading fast about what happened here. I have already gotten radio calls from 3 other fire bases asking for technical details on your system. Torres secured the last cable anchor. Good. If this helps other units maintain fire support capability, then today was worth it. Dalton sat down on an ammunition crate. I owe you an apology. When you first said you could fix this gun, I dismissed you. I thought you were overconfident and underqualified. I was wrong on both counts. Torres looked at him directly. You are not wrong to be skeptical, Sergeant. Field modifications are risky. Your caution was appropriate. The difference is I had the engineering knowledge to calculate the risk accurately. Most people do not have that background. Dalton nodded slowly. That is a fair point. but I also made assumptions based on factors that had nothing to do with your capability. Torres understood what he was not saying directly. Gender, rank, appearance. The automatic dismissal that came from bias rather than evaluation. She appreciated that he was acknowledging it now. Dalton continued. Jenkins and Martinez respect you completely now. So do the crews from the other guns. You earned that through performance, not talk. Torres allowed a slight smile. That is how it should be. Results matter more than promises. Captain Rodriguez found them as darkness fell. Torres, Battalion wants you to prepare a written technical manual for the recoil loop system. Include all calculations, material specifications, step-by-step implementation procedures, and maintenance protocols. Think you can have that completed in 3 days? Torres considered the scope of work. Yes, sir. I have most of the documentation already. Just needs proper formatting and detailed diagrams. Rodriguez nodded. Outstanding. One more thing. The Bronze Star recommendation is going through official channels. You will receive the award at a battalion ceremony next month. Torres felt the weight of that recognition, not just for engineering, but for leadership under fire. For making the hard calls when cables were at 98% thermal and a mission required 40 more rounds. For trusting her mathematics when everyone else saw only risk. She looked at Gun 2, its cable system gleaming in the fading light. The improvised recoil loop had proven itself beyond any doubt. Martinez joined her. Sergeant, what should we call this officially? The recoil loop system? Torres considered. The Torres improvised recoil dampening system sounds too formal. Let's just call it what it is. The cable recoil loop. Simple and descriptive. Jenkins overheard and grinned. Already heard some guys calling it the Torres loop. You're not going to escape having your name on this. Torres shrugged. If the name helps people remember the technique, I can live with it. The important thing is that it works and other units can implement it when needed. Dalton stood. Get some rest, all of you. Tomorrow we return to normal operations. But tonight, take a moment to realize what you accomplished. You kept this firebase in the fight when it mattered most. The crew dispersed. Torres remained beside Gun 2 for a few more minutes, running her hand along the cables that had held through everything. Mathematics had been her foundation. Engineering had been her tool. But trust in her own calculations under pressure had been what made the difference. She walked toward her quarters, already planning the technical manual in her head. The division artillery commander arrived at Firebase Cost 7 days after the battle. Brigadier General Patricia Hoffman had built her career on artillery innovation and was known throughout the Army for demanding technical precision. Torres stood beside Gun 2 as Hoffman's helicopter touched down. Captain Rodriguez had warned her that Hoffman would ask difficult questions and expect detailed answers. This was not a ceremonial visit. This was a technical evaluation. Hoffman exited the helicopter and walked directly to Gun 2 without small talk or pleasantries. She studied the cable configuration for a full minute in silence before speaking. Sergeant Torres, I have read your technical documentation. I need to see this system operate under combat conditions. Can you demonstrate a fire mission right now? Torres nodded. Yes, ma'am. We have a scheduled training fire in 15 minutes. I can demonstrate the system using live rounds. Hoffman, check her watch. Proceed. Torres moved to the gunner position while Jenkins and Martinez prepared ammunition. Dalton coordinated with Fire Direction Center to verify the training range was clear. Hoffman positioned herself where she could observe both the gun operation and the cable system behavior. Torres received firing data and elevated the barrel. The cables shifted smoothly with the gun movement. She fired the first round. The recoil loop engaged exactly as designed. Cables snapped taut, absorbed the force, flexed under load, and brought the barrel back to battery. Smooth and controlled. Hoffman stepped closer to examine the cables immediately after firing. Still warm. What is the thermal recovery time between missions? Torres consulted her notes. Depends on mission intensity, ma'am. Single rounds cool in 2 minutes. 5-round missions need 5 to 7 minutes. Sustained fire above 10 rounds requires 10 to 15 minutes between missions to maintain optimal cable temperature. Hoffman touched one of the anchor points. How do you verify cable integrity between missions? Torres showed her the inspection procedure. Visual examination for fraying or deformation. Tension verification using torque measurements. Thermal imaging to identify stress concentration points. Any cable showing where beyond tolerance gets replaced immediately. We maintain a ready stock of pre-cut cables to specification. Replacement takes approximately 6 minutes per cable. Hoffman made notes on a tablet. 6 minutes is faster than hydraulic buffer replacement. Torres confirmed. Yes, ma'am. And cables are more readily available through standard supply chains than specialized hydraulic components. Hoffman walked around the gun 3 times, examining the system from every angle. Her expression revealed nothing. Finally, she spoke. The engineering is sound. Load distribution follows proper structural mechanics. Material selection is appropriate for the stress environment. Thermal management protocols are comprehensive. My concern is reliability. You have tested this under combat conditions. I need to know the failure rate. Torres pulled out her maintenance log. 347 rounds fired since implementation. 1 secondary cable failure during maximum stress conditions. 0 primary cable failures. 0 mission failures due to system malfunction. Hoffman looked up sharply. 1 failure out of 347 rounds? Torres nodded. The failure occurred during a 40-round sustained fire mission at 98% thermal load. The secondary cable failed as predicted by material fatigue calculations. The primary cables compensated immediately and the mission completed successfully. The system performed exactly as designed. Hoffman studied the maintenance log closely. You predicted which cable would fail? Torres showed her the stress calculations. The secondary stabilizer cables experience combined thermal and lateral stress. Under extreme sustained fire, they reach fatigue threshold before primary cables. I designed the system with that failure mode in mind. Losing a secondary cable reduces lateral stability slightly, but does not compromise structural integrity. Hoffman was quiet for a long moment. This is graduate-level engineering, Sergeant. Where did you learn these calculations? Mit Mechanical Engineering, Mom. 2 years before I enlisted. Hoffman looked at Torres directly. Why did you leave MIT? Torres met her eyes. Family circumstances required it, ma'am. I do not regret the choice. The Army has given me opportunities to apply my engineering knowledge in ways I never anticipated. Hoffman nodded slowly. Captain Rodriguez tells me Lieutenant Colonel Morrison recommended you for officer candidate school. Torres confirmed. Yes, ma'am. I am considering it. Hoffman set down her tablet. Sergeant Torres, I am going to be direct. The Army desperately needs officers with your technical capability and problem-solving mindset. I am personally endorsing your OCS application if you choose to submit one. But that is your decision. Regardless of what you choose, I am authorizing fleet-wide implementation of your recoil loop system. Every artillery unit in theater will receive training and materials to implement this procedure. Your engineering is saving equipment and maintaining fire support capability across the division. Torres felt the magnitude of that statement. Her improvised fix on a broken gun was becoming standard doctrine. Jenkins approached cautiously. Ma'am, if I may speak? Hoffman gestured approval. Sergeant Torres could have played it safe and let this gun get deadlined. Instead, she took personal risk to test a system nobody had tried before. When everyone doubted it would work, she trusted her calculations. That takes courage on top of technical skill. Hoffman smiled slightly. I agree, Private. That is exactly the kind of leadership we need. Martinez added, Ma'am, I doubted Sergeant Torres when she first proposed this system. I thought she was being overconfident, but she explained the mathematics and showed us why it would work. Then she proved it under combat conditions. She earned our complete trust through competence and performance. Hoffman looked at Torres. Your crew clearly respects you. That matters as much as technical skill. Torres felt uncomfortable with the praise. They respect the engineering, ma'am. I just applied the mathematics correctly. Staff Sergeant Williams from Gun 4 had joined the group. Ma'am, I initially questioned whether this system was safe. I watched Sergeant Torres fire 40 rounds at maximum thermal load during the battle. The precision of her calculations was perfect. When that secondary cable failed exactly as she predicted it would, I realized I was watching engineering at the highest level. She knew what would fail, when it would fail, and how the system would compensate. That is not improvisation. That is mastery. Hoffman made more notes on her tablet. Dalton spoke up. Ma'am, I was the biggest skeptic. When Sergeant Torres first said she could fix this gun, I dismissed her proposal as theories. I recommended we deadline the gun and wait for proper parts. She proved me completely wrong. The recoil loop system performed better under sustained combat fire than I thought possible. I learned an important lesson about respecting technical expertise regardless of rank or preconceptions. Hoffman looked at Dalton with approval. Recognizing when you are wrong is a sign of good leadership, Sergeant. Captain Rodriguez joined the group. Ma'am, during the battle, Gun 2 fired 187 rounds while other guns experienced malfunctions and stoppages. Sergeant Torres managed thermal loads and cable stress in real time under enemy fire. Her decisions were technically sound and tactically appropriate. The improvised recoil loop became our most reliable fire support asset. Hoffman closed her tablet. I have seen enough. This system works. The engineering is exceptional. The implementation is professional. Sergeant Torres, you have my complete confidence and support. Hoffman turned to address everyone assembled. What happened here represents the best of Army values. Technical competence, innovative problem-solving, courage under fire, and adaptability in the face of challenges. Sergeant Torres took a broken weapon and made it the most reliable gun in the fire base. That is the standard I expect from every soldier. She turned back to Torres. Your technical manual will be distributed division-wide within 2 weeks. I am assigning you as subject matter expert for artillery innovation. You will brief other units and assist with implementation. Questions? Torres had none. Hoffman extended her hand. Outstanding work, Sergeant. The Army is better because of soldiers like you. Torres shook her hand, feeling the weight of recognition from someone whose opinion carried significant authority. As Hoffman departed, the crew gathered around Gun 2. Martinez touched one of the cables. We are part of something bigger now. This is not just our gun anymore. It is a system that will help artillery units across the division. Jenkins nodded, and everyone will know it started here, with Sergeant Torres and a notebook full of calculations. Dalton approached Torres privately. I want you to know something. When I doubted you, it was not just skepticism about the engineering. I made assumptions based on factors I should not have considered. You proved those assumptions wrong in every way possible. Thank you for that lesson. Torres looked at him directly. We all have biases, Sergeant. What matters is recognizing them and adjusting. You did that. Dalton nodded. The crew respects you completely now. So do I. That respect was earned through performance that nobody can question. The fire base returned to normal operations, but something fundamental had changed. Gun 2 was no longer just another howitzer. It was proof that engineering and determination could overcome equipment failure. The cables that Torres had installed a week ago now represented something larger than their physical function. They represented adaptability, competence, and the power of trusting mathematics over doubt. Torres stood beside the gun as evening fell, knowing that her improvised solution had become permanent doctrine. The recoil loop would serve artillery units across the division, and every cable installed would carry the lesson that technical capability and courage could solve problems that seemed impossible. 3 weeks after the battle, Torres stood at the Firebase Command Post briefing her 4th group of artillery crews on the recoil loop system. Representatives from 8 different units had rotated through Firebase COS to receive Hansen training. The improvised fix had become official doctrine, documented in field manuals and distributed across the division. Gun 2 served as the demonstration platform. Its cable system now considered the gold standard for emergency recoil management. A sergeant from Firebase Wilderness raised his hand. Sergeant Torres, what do you do when you cannot get the exact cable specifications? Do we substitute materials or abort the implementation? Torres showed him the material standards chart she had developed. The primary cables must meet minimum tensile strength of 10,000 pounds. If you cannot source exact specifications, you can use heavier gauge cables and adjust the anchor positions to compensate. The mathematics remain the same. Calculate your actual material strength, verify your load requirements, and position accordingly. Another soldier asked about thermal management in different climates. Torres pulled up data from her maintenance logs. We operate in high desert conditions here. Temperature affects cable performance. In colder environments, cables remain more rigid and require different tension settings. In extreme heat, you need more frequent cooling breaks. The principle stays constant, but implementation adjusts for local conditions. Monitor your cable temperatures and establish your own baseline performance data. After 2 hours, the training concluded. The visiting crews departed with comprehensive documentation and confidence they could implement the system if needed. Captain Rodriguez found Torres reviewing supply requests. The replacement hydraulic buffers finally arrived this morning. 3 weeks late, but they are here. Do you want to restore Gun 2 to standard configuration? Torres considered the question carefully. The recoil loop works. It has proven reliable under combat conditions. But she understood the value of returning to factory specifications when possible. Yes, sir. We should restore the hydraulic system. The recoil loop should remain an emergency backup procedure, not permanent configuration. Rodriguez nodded. Smart decision. Preserve the improvised system as a contingency option, but use proper equipment when available. Jenkins and Martinez helped Torres remove the cable system that afternoon. Each cable was carefully stored with its specifications documented for future reference. The new hydraulic buffer installed smoothly, restoring Gun 2 to manufacturer configuration. But something felt different now. The gun crew had absolute confidence in the artillery piece because they had seen it perform under impossible conditions. They knew that even catastrophic failure could be overcome with proper engineering. Dalton inspected the restored hydraulic system. Back to normal. But I'm keeping your cable documentation in my maintenance kit. If we ever need it again, we know it works. The Bronze Star ceremony took place the following week. Battalion formation assembled in the firebase courtyard. Lieutenant Colonel Morrison read the citation. For exceptionally meritorious service and heroic achievement in connection with military operations during sustained combat operations. Staff Sergeant Maya Torres demonstrated extraordinary technical competence, innovative problem-solving, and courage under fire. Her engineering solution maintained critical fire support capability during decisive engagement, directly contributing to the successful defense of firebase coast and saving numerous lives. Her actions reflect great credit upon herself and the United States Army. Morrison pinned the medal on Torres' uniform. The formation applauded. Jenkins and Martinez stood in the front row, pride evident on their faces. Dalton stood beside them, his earlier skepticism completely transformed into respect. After the ceremony, soldiers approached to congratulate her. Staff Sergeant Williams shook her hand. That medal is well-deserved. You changed how we think about equipment failure and field adaptation. Torres accepted the praise gracefully, but felt slightly uncomfortable with the attention. The engineering did the work. I just trusted the mathematics. Brigadier General Hoffman attended the ceremony and pulled Torres aside afterward. Have you made a decision about officer candidate school? Torres had been thinking about it constantly for 3 weeks. Yes, ma'am. I am submitting my application. The Army needs officers who understand both technical systems and tactical requirements. I think I can serve better in that capacity. Hoffman smiled. Excellent decision. You will make an outstanding officer. Your OCS class starts in 8 weeks. Use that time to prepare yourself for the transition from technical specialist to military leader. That evening, Torres walked to Gun 2 one final time as its crew chief. Martinez was conducting routine maintenance, following the procedures she had trained him on. Jenkins was organizing ammunition storage with precision she recognized as her influence. Dalton approached. Torres, the crew wanted me to tell you something. You change how we operate. Not just the technical procedures, but how we think about problems. You taught us that impossible challenges just require better engineering. Thank you for that. Torres looked at the gun that had started as a catastrophic failure and become a teaching platform for the entire division. The recoil loop system was now installed on 4 other fire bases as a contingency measure. Her technical manual had been downloaded over 200 times. Artillery crews across the theater knew the Torres loop by name and reputation. But what mattered most to her was standing here with Jenkins, Martinez, and Dalton, knowing they trusted her completely. That trust had been earned through competence, not granted through rank. Captain Rodriguez joined them. Torres, I received word from Division. You are being reassigned to the artillery schoolhouse as an instructor while you wait for your OCS class to start. They want you teaching advanced field maintenance and emergency adaptation procedures. Your recoil loop case study is becoming required curriculum. Torres felt the full weight of her journey. From a broken gun and dismissive skepticism to teaching the next generation of artillery soldiers how to adapt under pressure. The mathematics had been constant throughout. Her confidence in engineering principles had never wavered. But the human element, earning trust and respect through demonstrated capability, that had been the real challenge. Martinez spoke up. Sergeant, when you first said you could fix that gun, I did not believe you. I thought you were overconfident. I was wrong. You knew exactly what you were doing, and you had the courage to prove it. Jenkins added, you could have played it safe and let the gun stay deadlined. Instead, you took personal risk and responsibility. That is real leadership. Dalton extended his hand. Torres, I doubted you, and I was wrong. You proved that technical competence and determination can overcome any obstacle. I will not make that mistake again with anyone. Torres shook his hand. We all learn lessons here, Sergeant. I learned that trust has to be earned regardless of capability. You learn to evaluate people based on demonstrated competence rather than preconceptions. The crew learned that engineering can solve problems that seem impossible. Those lessons matter as much as the technical achievement. Rodriguez checked his watch. Torres, you have orders to report to the schoolhouse in 48 hours. Better start packing. She nodded and took one last look at Gun 2. Before we wrap this up, I want to ask you something. Have you ever faced a situation where you had to improvise a solution when the standard approach would not work? Maybe not in military context, but in your work, your projects, or your life. Have you ever trusted your knowledge and pushed through doubt to prove something could be done? Drop a comment and share your story, because that ability to adapt and innovate when circumstances demand it, that is a skill that transcends any single profession or challenge. Sometimes the best solutions come from trusting what you know and having the courage to implement it even when others doubt. The sun set over Firebase Coast as Torres walked toward her quarters. The improvised recoil loop had started as a desperate field repair and evolved into official doctrine. More importantly, it had proven that engineering principles applied with precision and courage could overcome equipment failure and skepticism. The cables were gone now, replaced by proper hydraulic systems. But the knowledge remained documented and distributed across the Army. Other artillery crews would face equipment failures and remember that Staff Sergeant Torres had looked at a broken gun and seen a solvable problem. 2 days later, Torres departed Firebase Coast. The crew gathered to see her off. Jenkins and Martinez saluted crisply. Dalton shook her hand one final time. Good luck at OCS. You're going to be an outstanding officer. Rodriguez handed her a framed photograph of Gun 2 with its cable recoil loop fully installed. Keep this as a reminder of what you accomplished here. Torres accepted the photo. The gun, the cables, the mathematics that held it all together. But more than the engineering, the faces in the background showed what mattered most. Jenkins loading rounds with complete trust. Martinez monitoring thermal readings with precision. Dalton coordinating fire missions with confidence. A crew that had transformed from skepticism to absolute faith in her capability. The helicopter lifted off. Torres watched Firebase Coast shrink below her. Somewhere down there, Gun 2 was firing support missions using its restored hydraulic buffer. But in maintenance storage, The cable recoil loop components remained ready, documented, and available if ever needed again. The improvised system that everyone had doubted had become the backup plan everyone trusted. Mathematics had proven stronger than skepticism. Engineering had overcome impossible odds. And one sergeant with a notebook and determination had shown that technical competence, when applied with precision and courage, could accomplish what others dismissed as theories. The Torres loop would endure not just as a technical procedure, but as proof that knowledge and confidence could turn catastrophic failure into innovative success.